Hello, hello. So now we're at the end. You've made it to the end of chapter 6. I am just filming these on the same day as I did the beginning of the chapter. I went ahead and turned my projector off so I could just write here on the whiteboard in my classroom. So there is no more huge projector circle, so hopefully that'll be a good thing. And there is a 10.6 video also of me from last spring, but it doesn't get into the depth in which I wanted to share with you. And so you could, I'm sure I do some of the same examples, but the very last example here today is going to get us to a level that I didn't do in the spring. So if you want to go and watch that, who knows if I say the exact same thing the exact same way every time I teach it. I'd probably do a lot of the same examples. So today we are going to learn how to solve, and I would write some steps out in my notes just so that you kind of have an algorithm. Okay, I have to do this, and then I need to do this, and then I need to do this. So the first thing you're going to do when looking at these problems is you're going to isolate the radical. The second thing you're going to do is take both sides to an exponent that clears the radical. So for instance, if your radical was a cube root, you would take both sides to the to the third power, because that would cancel that out. And so if it was the fourth root, you would take both sides to the fourth power, and so on and so forth, whatever the situation called for. If you saw how many pens I had over here on my desk, let's see if I can find one that writes a little better. I just got out a bunch of new ones. And then you're going to make sure you're going to solve. That didn't really improve things. And then you're going to check your answer. You need to check your answer when you're doing problems with radicals, because you can get solutions that aren't technically within the domain of, and that goes all the way back to 10.1, but you could end up with extra answers, basically. And we will look at that together, and so make sure you have those steps. And so I will keep those steps up when I do my first problem here. Bear with me. Here, I'll just arm myself with a few markers. See what we get. All right, so there we go. All right, the square root of x minus 3 equals 4. So it says isolate the radical. So you're going to get this radical by itself. So we're going to jump that 3 to the other side. So add 3, so we have the square root of x equals 7. And then we're going to take both sides to an exponent that clears the radical. So since this is a square root, we are going to square both sides. And so that is going to just cancel that out and break out of the radical anything that is underneath. So it literally just cancels. The same way multiply and divide undo each other, add and subtract undo each other. They are inverse functions. That also probably explains why this, what am I trying to say here? It explains why this key and this key on your calculator are most likely the same key, and you just have to use the shift button because they are inverse functions of one another. And so 7 times 7 is 49, and we're done. We need to check, so you need to plug that 49 back in and make sure, do you really get, you're checking, is that true? Do you really get 4? The square root of 49 is 7. 7 take away 3 is 4. So yes, it does check 4 equals 4, and you're good. Number 2. Let's try the square root of x plus 5 equals 3. So move the 5 to the other side, subtract 5, subtract 5. And so we have the square root of x equals -5. Take both sides to the second power, or square both sides. Cancels that right out and breaks that free. And then -5 times -5 is positive 25. And so there's our answer. But if we plug 25 in right here, the square root of 25 is 5. 5 plus 5 is 10. 10 is not equal to 3. And so here's an example, and it has to do with the negative and how we only took the principal square root and all those types of things. But this one does not check. And so we have to throw away the answer. And since in this question there's only one answer, we are going to say there is no answer and it's empty set. So don't leave it as a 0, because 0 is a real number. You have to do the slash. It is the set of empty set. There is no solution. All right, you can write out the words no solution. It just depends on how my math lab will want you to write that answer. All right, let's look at one where it's a fractional exponent. So here's this. And all of these, my instructions are the same all day. My instructions are to solve. So sorry I'm not writing the instruction piece out. And how do you know if you missed that? How do you know you're solving? Because there's an equal sign. So just a few little reminders there that you know when there's an equal sign, it's probably a solve. It will say solve at the top every single time. All right, so now we're going to get this piece isolated. We're going to get this piece by itself. So you're going to move that -5 over. And so we're going to take both sides to the exponent that clears the radical. Technically, we don't have a radical here. I have it in a fractional form, but it's the same meaning. So you are going to cube both sides so that clears that. So think reciprocal there. And so those things are just going to cancel out, because 1/3 multiplied by 3 over 1 is just 1. And so on the left, you have 2x plus 1. And on the right, you have -5 to the 3rd power. So it is a -5 times a -5 times a -5, or -125. So now we just solve for x. And we have -63. The ones that have an odd root always work when we check them. But if you wanted to check, because now you're in the habit of checking, let's plug that back in. So 2 times -63 plus 1, all to the 1/3 power, plus 5 equals 0. So this is -126 plus 1, which is -125 to the 1/3 power. So that is the cube root of 125, of -125, so that's -5. And so you can see it does check. All right. So some examples of differing kinds, and now we're going to look into ones that are starting to use a little bit more algebra skills. You thought you were going to get away without needing to factor maybe in chapter 10, like we've done so extensively in other chapters. And so we're going to look at this one right here. And now we do have to factor in this problem. So factoring is back. Hooray! All right, so what do we do? How do we start this? It says step 1 right here, isolate our radical. So we need to get this square root of x plus 7 by itself. So I'm going to move that 5 to the other side. So I'm going to get x minus 5 equals radical x plus 7. And I kind of like the radical on the left, I'm not going to lie. So you can rewrite the whole thing if you want. It's kind of like when you have x equals 3 or 3 equals x. This one just looks backwards. Okay, so I'm just going to take a quick second and rewrite it. So I just flipped everything. All right, so that's what we've got. All right, so now step 2, take both sides to an exponent that clears the radical. So I'm going to square this side, and I'm going to square this side. You're not just squaring the 5, you are squaring that whole thing. So be very careful there. So on the left, this is going to cancel this out, and you're going to end up with x plus 7. On the right, you need to FOIL. X minus 5, x minus 5, because you don't forget the middle term. So now that it's been maybe a week or so, it is not equal. Don't just do that. Don't just square this guy, and think you're done. You have to FOIL it. There's going to be a middle term. So I'm going to just continue to bring this x plus 7 down. This is going to be x squared minus 5x minus 5x plus 25. And so when I gather my like terms, this is x squared minus 10x plus 25. And now I can bring these two over because I've got the right-hand side simplified. So my strategy here, I'm still in this step to solve. My strategy here, once again, in order to solve something that's going to require factoring, you want to have this left-hand side be 0. You want to set it equal to 0, factor it, and solve each factor. So let's move this x over. Let's move that 7 over. And that's going to give us 0 on the left. Let me make sure I'm still in camera. Oh, I got lots of room. Well, maybe. 0 on the left. And then I've got x squared minus 11x plus 18. And so I need two factors that multiply to a positive 18, but add up to negative 11, which are 2 and 9. And so then my two factors are a positive 2 and a positive 9. And so I need to check those. I need to go back up to my original equation and do a quick check. So if I plug in 2 right here and 2 right here, let's see what I would get. I would get 2 equals 2 plus 7 is 9, so I'd have the square root of 9 plus 5. The square root of 9 is 3. So 2 equals 3 plus 2 does not equal 8. So when I plug 2 in, it does not check out. So that means you got to throw it away. All right? And if I go back and check my other answer, which is 9, put 9 here, put 9 here, I would get 9 equals 9 plus 7 is 16. The square root of 16 is 4. 4 plus 5 is 9, so it does check, so 9 is the answer. So sometimes both work, rarely do neither work. Usually if you have two answers, one work and one doesn't, but don't hold me to that. It all is dependent on what kind of question you end up with. So there's that one there. All right, and now we are working our way up to problems where I need the whole board. So do not try to save paper. I've got 3 of them. So I've got 2 to show you, and then I've got 1 for you to try. Perhaps you needed to try one like this. I just don't want to, it's not one I can make up off the top of my head, and I don't have my book open right here. So reach out to me if you have questions. So 2x minus 5. This is the problem that you will not see on the original video. All right, so what do we see that's different here? And hopefully you go, gosh, I see that I have 2 different radicals. All right, and so now what do we do if we have 2 radicals in the same problem? We're just gonna follow through with the steps. Isolate the square root. So step 1, is there a square root that's isolated? Absolutely, it's right here. Step 2 says, take both sides to a power that's gonna clear the radical. So if I square that, and then we learned in that last problem, we need to put parentheses right there, and then we can square that. All right. If I square a radical here, that's just gonna break that free, and I'm gonna end up with 2x minus 5. If I square this, it requires me to FOIL. And so I'm gonna since I have this on a whiteboard and I can erase, I am going to just come right over here and I'm gonna say, okay, what does this look like? So I need to first out in last this. And it does get a little complicated, so bear with me here. So 1 times 1 is the F of FOIL. The outside piece is 1 times radical x minus 3. There's the O. So plus 1 radical x minus 3. The inside piece is the I of FOIL. So plus 1 radical x minus 3. And the last piece is that multiplied by itself. Radical x minus 3 times another radical x minus 3, or plus radical x minus 3 squared. When you square a radical, it causes what's the radical piece to cancel. So here is my next step after foiling this piece right here. This is almost the hardest part of the whole deal, which is why I'm kind of just going slow with it. Now we're going to gather our like terms. So we have 1 radical x minus 3 and another 1 radical x minus 3. So I have 2 of them. I have a 1 right here, and I have a negative 3 right here, and I have this plus x right here. There is no other just x term, so I'll go ahead and write that down, and then 1 minus 3 is a negative 2. So this is what I get after I FOIL. And I pray that I don't make a mistake, because there's a lot of steps that are gonna come after that. So sometimes I might need to pause. I think I'm fine. We will see. All right, now what do we do? Because I notice I still have a radical in my problem. So now we're gonna repeat the steps, okay? So we're gonna isolate the radical, and then we're gonna square both sides again. And then we're gonna solve. Okay, so I'm gonna move both of these things over here to the left. I'm gonna go subtract x and add 2, subtract x and add 2, and I'm gonna get x minus 3 equals 2 radical x minus 3. And now it should start looking something familiar like the last problem we just did. So if you want to pause, you can try to finish it up. This is a great opportunity for that. What are we going to do? We're going to square both sides. Okay, what do you do with that 2? Just keep it right in there and square it. All right, so here you need to FOIL. So you have x minus 3 times x minus 3. So you have x squared minus 3x minus 3x plus 9. Or x squared minus 6x plus 9. On the right-hand side, you do just square that 2 on the outside. So I just wrapped that all up and squared it. You do need to square that 2. 2 times 2 is 4. And then this piece becomes a parenthesis. So when that breaks free of the radical, it looks like that. And then you go ahead and you distribute that 4. So 4x minus 12. All right, it is getting there. I'm gonna erase this piece. And again, I still hope that I don't do all this and I haven't made an error, because I need to now factor, and you're gonna know right away if you've made an error because something isn't gonna factor. And so what do I have? I have x squared minus 10x plus 21 equals 0. And so I see that it does factor x and x. 2 numbers that multiply to 21 and add up to negative 10 are 7 and 3. And so we finally get x equals 7 or x equals 3. So those are a lot of work when it has the double radical, no lie. All right, there will be one like this on the test, and I'll have one for you to try here in just a second. So we do need to check. How do you even check? Well, go back to your original problem. Imagine that I don't have those little squarey things there. And so my original problem looked like this. Radical 2x minus 5 equals 1 plus radical x minus 3. And we're going to plug in 7. And we're going to plug in 7. So 2 times 7 is 14 minus 5, which is 9. The square root of 9 is 3. On the right-hand side, 7 minus 3 is 4. The square root of 4 is 2. So 1 plus 2 is 3. And it definitely checks. So 7 is good. If you want to go and check 3 for an answer, then all of this would erase. So 2 times 3 is 6. 6 minus 5 is 1. The square root of 1 is 1. 3 minus 3 here on the right side is 0. And so then that's 1 equals 1. And so both work out. And so there you have it. All right, here's one for you to try. Oh, I did say I had 2 written down. I do have 2 written down. Well, you can always fast forward. I'll do one more and then I'll give you your try. So here's one more. This one is not as complicated. Just depends on how you set it up. All right, so I would probably, I feel like I want to get this one isolated first. So I would probably, since it's negative, I'm going to move this to the right and I'm going to move that to the left. So I'm going to add this over, it's going to become a plus. I'm going to subtract that. So I'm going to do some hopping over the equal sign here and end up with that. So I hope that wasn't too confusing. So I'm going to square both sides, which means this is the piece I need to FOIL. So radical 2x minus 1 times another radical 2x minus 1. So that times itself just breaks that free. And then the outside piece is minus 1 radical 2x. The inside piece is minus 1 radical 2x. And the last piece here is going to be a plus 1. And maybe it was confusing to you how I got that. So let me just, if I multiply that by itself, it's squaring it. And so that's why it is just plain old 2x. All right, so these are like terms here. These are not like terms there. And so on the left-hand side, I am gonna have 2x plus 1 minus 2 radical 2x. And on the right-hand side, I'm gonna have x plus 1. So I need to get the square root by itself once again, and so I'm gonna move these things over, and then everything's gonna be negative, so I'll show you how to handle that. So if I have minus 2x minus 2x, take away 1, take away 1, oh, look at what's gonna happen. So I have negative 2 radical 2x equals minus 1x, and then those go away. All right, since both sides are negative, those negatives are just going to cancel. And so now, once again, I can square both sides to get rid of that radical sign. And so I'm going to have 4, because I have to square that too, parentheses 2x equals, and then on this side, I am going to have x squared. And so that doesn't work out so well. Did I write it down wrong? Minus equals 1. I don't know if I wrote it down off the book wrong. And maybe this is supposed to end up being a plus 1, because this is just not really going to work out unless my answer is 0. So 8x equals x squared, and so the only possibility here, let's take this all to the right, x squared minus 8x. Well, I guess this could be, I just don't recall this being the answer. So if I factor, oh, you're getting the authentic version here of me being utterly kind of baffled. I get those two answers right there, which seems odd to me. So let me plug in, if this is 8, oh, well, that might work out nice. If this is 8, all the thoughts of Jenny McNutt happening right now. That is 16 minus 3, which is 5, so that's not going to work. If that is 0, all right, so yeah, I'm going to stand by that I didn't write it down incorrectly, and I'll show you this check a little bit more thoroughly here. All right, so if I plug in, so let's go back up to here just to do a better job. All right, 4 times 2 gives me 8x. Whenever I have an x squared and an x term, I've got to get everybody to one side. I had just a GCF of x. That's all I could factor out front. So this outside factor gives me the answer of 0. This inside factor gives me the answer of 8. And now I will check it real quick. So 2 times 8 is the square root of 16, which is 4, minus 8 plus 1 is the square root of 9, which is 3. And so 1 equals, oh, it does work. 1 equals 1. And so the 8 works out fine. And then if I have 0 for an answer, this would turn into 0, so that would just go away. And here, minus the square root of 1. Oh, I was wrong, because that negative is going to make that a negative 1. Those things are not equal. So this one I actually am going to ditch. Excuse me. And that one works out fine. All right, full of surprises. Here's your try. I'm wondering if you think that I speak louder in my classroom because I don't have to really watch my voice and when I'm in this huge room, as opposed to everybody doing online school at various times in the house or trying to do their jobs earlier in the semester. So there's your try. And it doesn't have two radicals. So I would still try that one. And I will find you one real quick that has two radicals that we can try. Might be one of your homework ones. I have several written down here. Okay, we'll try this one. So I'm glad I just didn't see that I had this written as a try. We could have introduced this earlier. So I'm going to move this to the left. I'm going to get x minus 10 equals radical x plus 10. We're going to square both sides. Oh, I'm happy that you have one like this to try though. So we're going to square both sides. We're going to get x minus 10 times x minus 10, which means you need to FOIL. So x squared minus 10x minus 10x plus 100, or x squared minus 20x plus 100. And on the right-hand side, bringing that down, when you square that radical, you get x plus 10. Get everybody on one side. So we're going to subtract that x, subtract that 10, subtract the x and the 10, and we end up with x squared minus 21x plus 90 equals 0. So now I am looking for factors of 90 that make a negative 21, and I feel like, let's see, factors of 90 that make a negative 21. X 15 and 6. 15 and 6. Whew, I almost thought I made a mistake there. 15 and 6 equals 0. And so x equals 15 and x equals 6. And those are both positive. So let's go back up here and check. So if I plug 15 in, I get the square root of 15 plus 10, which is 25, which is 5. So 5 plus 10 is 15. So this one works out fine. If I check 6, so this is going to be 16. The square root of 16 is 4. So this is not going to check. And so that one we throw out. So there's your first one to try. And now let's try one with a double radical. All right. So we're going to have radical 4x minus 3 equals 2 plus radical 2x minus 5. So there's your try. You can immediately go into squaring both sides because you do have a radical that's isolated right here. So here's step 1. If you want to pause, try a few things on your own. We're going to cancel that. And then this, I always kind of like to work this out maybe over here. All right, 2 times 2 is 4. The outside piece plus 2 radical 2x minus 5. The inside piece. And the last piece is just going to kill off that square root. And so it's going to be 2x minus 5 because it's going to be this times itself. And so when you multiply anything by itself, it's just going to kill off that radical. Okay. So we have 2 plus 2 is 4. So I have 4 radical 2x minus 5. That 4 and that negative 5 make a negative 1, and I have that 2x right there. So I've got 2x minus 1 plus 4 radical 2x minus 5. I don't know why I switched the order. I just wanted the radical in the back. Okay, so now I'm going to get this guy by itself. So I'm going to move these two things to the left. So negative 2x, and I'm going to change that to a positive 1. So I have 2x minus 2 equaling 4 radical 2x minus 5. All right, what I notice here is that this, and this are all have a common factor of 2. There's a GCF. So if I wanted to pull a 2 out, this is a little bit tricky. It works if you don't do it. I'm just going to end up with smaller numbers. So I would probably do something like this. And so then those just cancel. So that is going to make that just a little bit easier. I'm going to square both sides. Again, it works if you don't do it, but that's just going to make those numbers smaller and easier to FOIL. So we have x minus 1 times x minus 1, or x squared minus 1x minus 1x plus 1 equals, on this side, when I square this, 2 times 2 is 4, parentheses 2x minus 5. So I'm going to bring that, I'm just going to rewrite, and I might distribute that as I rewrite it. 8x minus 20. So I'm going to bring everybody over to the left. Oh, what do you know? This is so wild. I feel like we just did this factoring. So these must be common answers to end up with. We just factored this with the 3 and the 7. So again, not everybody, some weird coincidences have happened on my lessons I've done today, but that factors, and then my answers are 3 and 7. Does that match the first time? Yes. And I have little notes to myself that both are okay. So both must check, but I can show you. So square root of 4 times 3 minus 3, that's going to be the square root of 9, so that side is 3. On the right-hand side, 2 plus 2 times 3 minus 5, this is just 1, the square root of 1 is 1, so 2 plus 1, so 3 equals 3. And then if I put in 7, 4 times 7 is 28, take away 3 is 25, so radical 25 is 5. On the right-hand side, 2 plus 2 times 7, forget, this is just a piece of tape I can't get off my board, minus 5 is 14, minus 5 is 9. So the square root of 9 is 3, and so 5 equals 5. So if you checked them, that should check out because of that work right there. All right, this is as hard as chapter 6 gets. So you are done Hooray. No, I'm a liar. You have 10.8 left. I am done because I believe that lesson is already up on YouTube. So I hope you find success. I definitely understand not very many people are reaching out to me for help at the point in which I am recording this, which I think you guys are kind of halfway through chapter 6 right now, according to the syllabus. So please, 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 if you have questions on these, I'm happy to work something out, send it back to you, and any other ways I can help. So take care, and thanks for watching.